Okay, let's have a little fun here. And I have a pop quiz for you. Now, we all love pop quizzes. And this particular pop quiz is going to be on functions. And it's only going to be four questions, and it'll literally probably take you all of about less than 5 minutes to do. I'll show you the questions here in a second. We have four questions. That will take you under 5 minutes if you know what you're doing about functions. But if you don't, get through all of these questions. Don't panic, just use this as feedback. And of course, this isn't entirely conclusive either because there's a lot more topics that are not in this particular quiz about functions, but this is a good start. And this quiz would be appropriate for anyone that has taken anything at the, like, let's say the Algebra 1 level, first year high school algebra or beyond. So if you've taken any course at that level, if you're in pre-algebra, some of this might be a little bit beyond where you're currently at. But if you've taken anything, again, at the high school level in terms of algebra, you should be able to handle this. Okay, I don't know if you'll remember everything, but we'll go through these very important questions because what I'm going to be talking about in this quiz are kind of foundational concepts that, even if you've taken Algebra 1, a few years ago, you should hopefully remember some of this stuff. So we're going to get to all this in just one second. But first, let me quickly introduce myself. My name is John. I'm the founder of TabletClass Math. I'm also a middle and high school math teacher. I'm going to leave a link to my math help program in the description of this video. But basically, I've committed decades to developing what I like to believe is one of the best independent learning systems there is when it comes to mathematics because I've just seen so many students struggle through the years, either from a lack of confidence or just not being able to have enough time with a teacher. So I really kind of felt compelled to build what I think is a truly unique math help system. So if you kind of feel lost, in mathematics or overwhelmed and you're at the middle school, high school, or college level in terms of your math courses, I can definitely help you out. You definitely want to check out my math help program. It's kind of custom made for those of you that are in that situation. Now, if you are preparing for any test like the GED, SAT, ACT, anything that has math on it, okay, there's a ton of these different type of tests that you have to take, get into graduate school or become a teacher. There's just a wide variety of professional tests, school tests, college tests that you have to take, placement tests that have a math section on it. I have a ton of test prep courses. I put a lot of effort, a real strong, successful track record in helping those of you out there that are going to be taking these tests pass successfully. So you definitely want to check out my full course catalog because that can help you tremendously. If you homeschool, you absolutely have to check out my homeschool math program. I've been helping homeschoolers for a long time, many, many years successfully. Hey, by the way, if you don't have any math notes, you can use my math notes. I'm going to leave links to my math notes in the description of this video. But just believe me, I'm going to give you a great tip for today. Note taking is more important than you think it is. Okay, if you want awesome grades in mathematics, you got to start taking awesome math notes. Okay, so let's get into this functions quiz. Again, this is just a 4-question pop quiz. And let me show you the questions, and then I'll go through the answers. So first question is, I have two functions, f of x is equal to 2x plus 1, and g of x is equal to 3x minus 2. I'd like you to find this. Okay, I'm going to show you all the questions, and I'll come back to this here so you can see it. Our second question is going to be, is this a function? Okay, so I got some stuff down here, a set of numbers, and I want you to answer yes or no, but in order to get this particular problem right, you have to justify your answer. Okay, just not going to get lucky, be like, yes, it is, or no, it isn't. You got to give me an explanation. Again, I'm going to come back to these problems. I just want to show you each of the problems here. The third question is, the graph of a function and its inverse is symmetric along what line? Okay, so again, this particular question, hopefully most of you know this, but if you don't, I'm of course going to answer this here in just a second. And then our last question is, I want you to find the domain of this function here. Okay, h of t is equal to 2t, square root of 2t minus 1. And then I'm talking about here with respect to the real numbers. So I want the domain with respect to the real numbers. A little technical detail, but it does make a big difference in this problem. So let's go back up here and go ahead and start with questions 1 and 2. And then I'll wait for a few seconds here. If you want to pause the video, go ahead and do that. work on these problems, and then I'll scroll down to questions 3 and 4, and then I'm going to go through the answers. Okay, so hopefully you have finished questions 1 and 2. Again, if you need more time, just pause the video and let's take a look at questions 3 and 4. All right, so here's questions 3 and 4. Again, this is totally not a conclusive functions. This is not a function test. It's just a function pop quiz, random topics. Okay, so if you need more time before you work on these problems, before you see the solution, go ahead and continue to pause the video. But I'm going to answer the questions now, and we're going to see how well you have done with this little quiz. Okay, so let's get into it. All right, so our first question is, we got a function, f of x is equal to 2x plus 1, and g of x is equal to 3x minus 2. Here is the answer. F of x is equal to 6x minus 3. So if you got that right, that's pretty awesome. Let me go ahead and give you a happy face with a check mark. Very, very good. But what are we talking about here? We're talking about composite functions, and this is generally a point where students, or a topic where students get confused with initially when you're studying functions and function operations, because this notation right here is quite confusing. By the way, a couple suggestions here. If you need any help on functions in my math help program, all of my algebra courses, really I teach functions thoroughly. I teach it more basically in my pre-algebra course, but my Algebra 1, Algebra 2, pre-calculus, all those courses, college algebra, I really get heavy duty into functions. Of course, my pre-calculus course, we go really deep into functions. But anyways, again, functions is one of these topics that you start learning a little bit about in pre-algebra, more in Algebra 1 and Algebra 2. Just kind of continue to learn more about these particular topics. But anyways, this is a composite function. So if you didn't get this right, you need to review composite functions. But namely, what this notation is saying is we want to plug in the g of x function into the f function. So if you're going to evaluate this function here, for example, if I wanted to find f of 3, I would plug in a 3 right there. Okay, so that would be 2 times 3 plus 1 would be the value of f of 3. But with the composite function, what are you plugging in? Well, you're plugging in the g of x function. So this notation, don't let this confuse you. What this is really asking you is to plug in this into this function right there. Okay, so you're really kind of technically finding f of 3x minus 2. Okay, so we plug in 3x minus 2 right there, and then we go ahead and simplify the remaining thing, or the remaining expression there. So this is going to be 2 times 3x minus 2, which of course is the g of x function, and then we're going to add 1 to it. Okay, can't forget this part. So this is going to be what? 6x times 2 times 2 is negative 4. And so we got 6x minus 4 plus 1, and that gives us 6x minus 3, which of course is f of g of x in this particular problem. All right, so we got that right. Very good. And now let's move on to our next question. Okay, so is this a function? Again, I need some sort of justification, some sort of explanation, because if you answer this correctly without justifying this, then you wouldn't get any points. Okay, so let's just kind of really take a hard look at this and see if you know how to answer this question. Now, there's a couple different ways you could answer this question. This is, I think, is the easiest. So what we have here is a set of XY points. Okay, so this is a point, and we could plot these points on an XY coordinate plane. But a great way to evaluate whether a set of points, and technically in mathematics, this is called a relation. What I could do is plot this relation in a mapping diagram, and then we can kind of address what's going on here. So this is what you want to do. So again, each one of these points, this is an XY ordered pair. Okay, so right here, this 1 is X, this 3 is Y, so this is an XY point. Okay, so we're going to map our X's to the Y's. This is a mapping diagram, and you should be familiar with this, again, if you've studied functions. You got to be able to read mapping diagrams and construct them. So all we're going to do is just start taking each one of these points and map them. Okay, the X mapping to the Y. So here, 1 maps to 3. Okay, so that's that point. But I have 1 again over here, so 1 maps to 4 as well. Okay, so that's why I'm starting with the X's here. So we have This one is an x, and this one is also an x, so that's why I'm going to start like this way. 1 maps to 3, and 1 maps to 4, and then now we got 2 mapping to 5, and then 5 mapping to 2. So you can see my answer here is no, this is not a function, but why? Okay, well, after we constructed this mapping diagram, the deal is this, okay? For something to be a function, for a relation to be a function, each x can map to one and only one y value, okay? Every x can only point to one and only one y value, and here, this one is mapping to both 3 and 4. Okay, so this is a no-no with respect to functions. Okay, so that is kind of the definition of a function. It is a relation such that each x maps to, okay, one and only one y value. That's why we like to use mapping diagrams, because it's very easy to see this visually, that this one is, going to both 3 and 4. Again, there's more further explanation that I can get into about the definition of functions, but hopefully you were able to get this right. And if you got this right, then let me go ahead and give you a nice little happy face and 2 check marks if you got the previous question correct. So that's pretty good. So let's go ahead and continue on to the next question. All right, so the next question is the graph of the function. The graph of a function and its inverse, and that's assuming it does have an inverse, because not all functions have an inverse, but the graph of a function and its inverse is symmetric along what line? And that is the y equals x line, or y equals x axis. Okay, so it's very, very important. So for example, if I had this as my function right here, okay, let's say I had this as my function, this line right here would be symmetric. This would be my inverse function. I don't know if you can really see that, but there's symmetry along the y equals x line. Okay, and of course if I was to actually plot this, you would want to make this dotted just to show that that's just there as a reference. But that's y equals x is the line, or the axis of symmetry for when we have a function and its inverse. Now here is a bonus question for you. Okay, so what type of functions have an inverse? Okay, what type of functions have an inverse? Oh boy, this is a major pop pop quiz question here. This is a bonus, right? So if you want to get back in the school days when you got 100%, and then if you got the bonus question, some of you would end up, coming home to your parents and be like, hey, look, I got 110%, and your parents would be amazed, be like, how did you possibly get more than 100? Because I got the bonus question right. Well, here's the bonus question. So what type of functions have an inverse? Okay. Well, those are one-to-one functions, one-to-one functions. So for example, let me just throw in this little bonus explanation. So we got this question right on the axis of symmetry. That's excellent. But let's take a parabola. This is stuff that you should know here. Okay, is a parabola or quadratic function a function? Well, it is, because why? Well, graphically, you want to understand this thing called the vertical line test. Okay, so anywhere I draw a vertical line through this parabola, that vertical line will only chop through that graph one time. Okay, so that passes the vertical line test. So if something passes the vertical line test, that's a graphical test to determine whether that is a function. Okay, so but here's the deal: just because something's a function, it may not be a one-to-one function, and it may not have an inverse. Now, to know whether a function has an inverse, it also has to pass the HLT, the horizontal line test. So, for example, here with this parabola, how many times is a horizontal line chopping through that graph? Well, this is going through 2 times, okay? So this fails the HLT. So although the parabola, this graph of this quadratic equation or quadratic function, it is in fact a function, it's not a one-to-one function, therefore it does not have an inverse, okay? So again, we're not covering everything in this particular quiz, but this was your bonus question for today. So if you understand the VLT and HLT, well, that's pretty awesome. I must go ahead and give you a awesome happy face, and we'll give you 3 check marks. Matter of fact, 4 check marks, because if you get the bonus question right and all these other questions right, you've already aced this quiz. But let's go ahead and finish up with this last question here. And that is, we want to find the domain of this function. Okay, so h of t is equal to the square root of 2t minus 1, and we're going to want to find the domain with respect to the real number system. Okay, so how do we do this? Well, we can't take the square root of negative numbers in the real number system. Okay, as soon as you start taking the square root of negative numbers, like the square root of negative 16, you end up with an imaginary complex number. And I said, hey, no, keep this within the real number system in terms of your domain. So therefore, we have to, we can only take the square root of 0, which of course is 0, in the square root of positive numbers. So 2t minus 1 has to be, okay, it has to be either 0 or a positive number. So the way we do that, we say, okay, 2t minus 1, you have to be greater than or equal to 0, and that's just a mathematical way of saying, hey, you have to be 0 or greater, okay? So we're going to go ahead and solve this inequality. So you can see here I'm going to add 1 to both sides. I get 2t is greater than or equal to 1. And then I'm going to divide both sides of the equation by 2. And I get t is greater than or equal to 1/2. So this is basically the values of t that will satisfy these two conditions. Okay, so this is the domain. So technically, there's a lot of different ways you can express this. You could write it this way: the domain is all t is greater than or equal to 1, such that t is an element or part of the real number system. You can also use interval notation. That would look like this. Let's see here. It's going to be t is greater than or equal to 1/2. Now here is an extra bonus question. If you can use interval notation here, that's pretty awesome. So the interval notation would be 1/2 to positive infinity. Okay, so all t's. You could do it this way if you really want to get fancy, such all t such that t is an element of the real numbers. There's a lot of different mathematical notation to express intervals, okay, but this is another more advanced one. So if you're not familiar with this, don't worry about it. As long as you understand that t has got to be greater than equal to 1/2, that's all that you could plug into. If you plug in a t that's less than 1/2, you're going to run into problems, and that's not going to be part of the domain. All right, so how did you do? Okay, if you got all these questions right, and the bonus, well, then you are well on your way of just getting my 1987 Extra Aquanet hairspray Mohawk with an A plus 100%. Matter of fact, you might be so good at math. I mean, like, I don't know what you're doing. You might be watching that guy on YouTube, but that's pretty awesome. Okay, now if you didn't get any of these questions right, don't panic. Use this as feedback. You know, let's try to make math a little fun here. If you got a couple of these questions right, that's excellent. Okay, but again, when it comes to functions, this is a tremendously important topic in algebra. You see this word everywhere, functions. You've got to really understand this stuff. So again, it depends on where you're at, you know, in your current state of your math education, right? This is, again, you know, people panic. They're like, oh, I failed this. Doesn't make a difference. That just means you're right here on this ladder of knowledge. You just got to keep climbing these steps. And that's what my job is to help you climb these particular steps. Anyone can do this stuff, all right? But you got to have the right teacher. You got to have the right support, and you got to put in the time and effort. But if you kind of have that mix all together, you will be successful in math. All right, so hopefully this video helped you out. And if that is the case, don't forget to smash that like button. And if you're new to my YouTube channel, don't forget to subscribe. I've been on YouTube for a long time, 10 plus years, have over 1,000 plus math videos, basic to advanced mathematics, all there for you. But my best math help will always be within my math help program. Okay, so with that being said, I definitely wish you all the best in your mathematics adventures. Thank you for your time and have a great day.